In this video, we're going to be talking about evaluating functions. First, you need to know what a function is, and so we're going to describe a function versus a relation, as it is a basic aspect of understanding how our relationships work. A function is a relation between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one input. Or more simply stated, for every one input, there is one and only one output. So for every x value that you put in, you're only going to get one y value out instead of getting two different y values out. So that's important for us as we try to work through evaluating our functions so we know how many solutions there are. So let's take a look at some graphs to understand what is or is not a function. Here we have three different graphs, all with a red line placed through them. Now the red line isn't a part of the graph, but it does help us visualize whether there is one input for every one output. And what we call that vertical line that you kind of pass through each of these graphs is the vertical line test. Now the vertical line test is what happens if you pass a vertical line through your graph. If it ever touches your graph more than once as you pass it through left to right, that means it is not a function. So that's why the first example is a function. The second example is also a function because as we pass this red line through it, it only touches it once. Now why we do a vertical line is because it represents inputs, right? Because inputs are x values, so this is at a certain x value, this is at a certain x value, and this red line is at a certain x value. So as you pass this red line through it, over here it's still okay because it only touches that graph once. But as I get to this location, you can see that that graph intersects the vertical line 1, 2, 3 different times. So for that one x value, whatever this x value is, there are actually 3 different outputs for that graph. So it is no longer a function. It's still a relation because a relation represents just any relationship between x and y. And you can see there is an interesting looking graph that relates those two, but it's not a functional relationship. So when something is a function, for every one input, there's only one output. What that means for us is that we can use a different sort of notation to represent those relationships. We're used to a lot of our equations be written in y equals form. It's easier for graphing because you can plot your x and y values because you can see that if you were to plug 1 in for x, you're going to get 17 out for y, and you could plot that as a point in either of these examples. And that's great. But function notation is easier for plugging in values or other expressions and also naming one equation versus another. So here I have f of x, that is how it is stated. And we also have g of x, that's how that's stated. So you can see in quotations here, f of x and g of x. So where x is your input because that is inside these parentheses. These parentheses do not mean multiplication. It's a different notation to represent that this function is with respect to x, and we name it f. And so the naming aspect of it is important because in some scenarios I may want you to plug into f with the x value like 1. In other scenarios I may want you to plug in g with an x value of 1. So let's take a look at inputs and outputs. As we look at these relationships, it's going to be important for you to know what we mean by the input. That is always where the x is in the equation, and the output is the value you get out for that f of x. So if you had an x value, it would be placed into that x location in either one of those relationships. And whatever comes out of that is going to be this whole value of f of x, not just the g, not just the f, not just the x, but all of that on the left side there. So all of that value would be considered the output. So here I'm asking you to evaluate f of 2 and g of 3. So f of 2 means that 2 is the input, and that's going to go in for x, and it's going to go in for x in the f equation, not in the g, and that's pretty obvious because it's an f stated there. Whereas g of 3 is now the input, and that's going to go in this location for x. So let's do f of 2 real quick. So that means we want to plug 2 in for x. So you're going to have 10 times 2, and then you're still going to have to plus 7. And now let's just do evaluate. 10 times 2 is 20, plus 7 then is going to equal 27. And as we do g of 3, that means we're going to plug 3 in for x, which means it'll go right here. So you have negative 2 times a 3 squared then, and you have a plus 7 afterwards. And so now it's just order of operations. Negative 2 times 9 is 3 squared plus 7. That's negative 18 plus 7, or your answer is negative 11. So both of these are examples of where you're taking whatever is inside these parentheses and plugging it in place of x in your expression. Now we're going to take a look at what happens if I ask you to determine what input gives you a certain output. So these scenarios look like this instead, where you have the function f of x is already set equal to a value. So we're saying that this output f of x is 87 and the output of g of x is 5. So what that means is that I don't know the value of x, that's why there is an x written here, and I want you to find that value of x. So to solve that one for the first example, we start with 87 is equal to 10x plus 7. So my 87 is what f of x is equal, so that goes in this location, and it's still equal to 10x plus 7. My goal is to solve for x. So in that example, you would just subtract 7 on both sides, and then you have 80 is equal to 10x, and you divide by 10, so x would equal 10. So here I have found the input of 10 that gives you an output of 87. Same goes for the g of x function. So as we set that up, you have 5 equals negative 2x squared plus 7. Same idea. 5 is the output, so that goes here. I'm looking for the input of x. So you just solve this algebraically. You're going to subtract 7 again first. And so that will give us a negative 2 is equal to negative 2x squared. Then you divide by that negative 2 first in order to get your x part alone. And so that gives you 1 equals x squared. Make sure that you are dividing first, not trying to do a square root. The square is only the square of the x. That's why you need to get rid of the negative 2 first. And finally, to be able to solve, you're going to have to do the square root, but don't forget the plus and minus that exists when you're putting in the square root yourself. Because in here, our solutions could either be x equals 1 or negative 1 for our answers. And those are the two inputs in this scenario that give you that one single output of 5. So to try to sum it up, if you are given the value of a certain number in place of x, like f of 2 or g of 3, you simply plug that in place of x and solve. If you are not given the x, it'll look something like this, where the output of your function f is equal to some value. You set your equation equal to it and solve.